Hello and welcome back. In this video we're going to introduce the for loop or for statement, which allows us to iterate through the series of elements contained in a list or sequence. So the general syntax is a new keyword for us in Python, for, then some variable that's going to be assigned to each of the elements in a sequence in turn. So for variable in some list or sequence, then colon, and then a block of statements, one statement or a series of statements, all indented to show that they are contained within the for loop. Now what that's going to do is sequentially perform the given statements in the block for each of the elements in the list. So variable is bound to each of the elements in the list in turn, and we do all of the statements contained within the statement block for each of those elements in the list. So it's called a for loop or a for each loop. And here's a simple example that we have prepared in Wing IDE 101. I'm saying for I, which is a variable, it's going to be bound in turn to each of the values contained within this list, 0, 1, 2, 3, 4, 5, 6. So the first time we execute these two statements contained within the for block, I will be bound to 0. So we'll make I square equals 0 times 0, and we'll then print out, execute this print statement to print out both the value of I and the value of it squared. Having done it for 0, I will then be bound to the value 1, and we'll execute both of those statements. Then I will be bound to the value 2, and so on and so on and so on. So hopefully you can guess what output you'll see when we execute this. We're going to see a series of pieces of output produced by this print statement here, first with I bound to 0, then with I bound to 1, 2, 3, 4, 5, and 6. Okay, so we've really gained a lot of processing power here in terms of our ability to program things, because now we can have a series of statements executed again and again to iterate across all of the members of a list. There are visualizations you can use if you're wanting to inspect this more, and there's a link to one right there using the interactive Python tutor. Okay, so if we look again at a flowchart for what a for loop is doing, so a very simple loop here for num in some list, 10, 20, 50, and minus 30. What's going to happen is our flowchart essentially says at the beginning of the list, at the beginning of the for loop, it says, have we done all of the elements yet? If the answer to that is yes, we move on to whatever statement is following our for statement, and following the for statement and the statements included within the for loop. Otherwise, if we haven't yet processed all of the elements in our list, we'll just make num refer to the next element in the list, and then we'll print out that number. And then we go back to the start again and say, have we done all the elements in the list yet? And if the answer to that is no, we make num refer to the next element, and so on and so on and so on. So some terminology here, we say the loop control variable, which in this case is num, is bound to each of the elements in the list in turn. Okay, so this example is called a print loop. We're going to look at some patterns that we use in programming. So these are styles of programming that come up again and again and again. So common ways of solving particular problems, and they're building blocks that we use for solving larger problems. Some of these, and I'm going to break them up into separate videos, is the accumulator pattern, then the mapped list pattern, filtered list, counting loop pattern, and updated list. And you'll see similar features emerging across many of these different patterns. Okay, I'll do the accumulator pattern in this video and then pause so you can try some of this stuff yourself. So if we want to find the sum of the elements in a particular list of ints, well, if we're smart, we'll do that using the sum function that we already know is defined for us for lists. But let's say that sum function wasn't provided for us and we wanted to write it ourselves. How would we go about doing this? Well, one solution would be to keep a running total. So you start off with a total that is 0, and then as you visit each element in the list, you add to that total. So here's the solution to that, and you can see it on the bottom right here. So we start off by saying the total so far is 0, so we initialize our counter variable to 0. That's our running total. Then we say for num in data, where data is a list that we pass into this, this piece of code, we'll say total equals total plus num. So what I'm going to do is add an assignment statement here to initialize some data. So let's say data equals a list that is 0, 1, 2, 3, 4, 99, 90, 98. Okay, so there's a series of elements in a list. It's just a list of int values. We're going to start off saying that the total is 0, and when one by one we'll bind num to each of the elements in this list. So the first time we go around, we'll say total equals total, which is currently 0, plus num, which is 0, so total will be 0 after our first iteration. Then it'll be total, num will be bound to 1. And we'll say total equals total plus 1, which gives us a total of 1. I'm sure you can trace through this in your own time if you want, but let's run that and see what the answer is. We'll see it down in the shell. The total sum of all of those values is 207. So this is called the accumulator pattern, where a variable is used to keep a running total of the things that we've seen so far. The general form of the accumulator pattern is that some accumulator variable, like total in this example, has some initial value, and 0 is a sensible initial value for our running total. And then we say for element in some list of elements, update the accumulator variable according to that element. And that update may be a simple addition, like the previous slide, but it may be more complex, such as conditional on some value of an element, like add up all the odd elements in a list, or add up all of the even elements in the list, or something like that. And it may even involve multiple accumulators. So, for instance, finding both the maximum and minimum values contained within a list. Some examples of accumulator patterns that you might want to choose to do yourself. Find the maximum element in a list of numbers. Obviously, if you remember from earlier, there's already a max function built into lists, but you're going to solve it using an accumulator pattern and pretend that that max function doesn't exist. Or the min, or both the maximum and the minimum elements in one iteration through the list. Or the sum of squares for all elements in a list. Or the nearest matching, or the nearest pair of numbers, so any two numbers that differ in a list, any two neighboring numbers in a list that differ by the smallest possible value, and then return that answer. So you give those a go, and in the next video we'll start looking at some more patterns. Thanks.